Hey guys, what's going on today? We've got the Newton's rocket law, the Newton's laws rocket lab today, and today I'm just going to try to go through some of this and help you guys out to get started here. Okay, so here I've recorded some values that you most likely did not get. Okay, especially if you watched the video, if you enjoyed it, and what I'm going to use some different numbers and kind of go through maybe using my numbers, and you should be able to kind of follow along, and then you should be able to do them with your numbers that you came up with. Okay, so first thing I'm going to do is, remember, we're going to find the average time, and we're finding the average time for all 6 of these values. If I add all those up, I get 60, but remember, to find the average, we're going to divide them by 6. So 60 over 6, we get average time of 10. 10 seconds, okay? So in our analysis questions, how long did the rocket take to reach the maximum height from launch? Well, remember that the flight of a rocket is like a parabola, right? So it's launched, it goes up and up and up, and then it stops. Now when it stops, that's like halfway through the launch. So halfway through the launch, that's how long it took to reach the maximum height. What's half of 10? So for mine, I'm going to put 5 seconds. Okay, and then how long did it take to fall to the ground? Okay, well, what's left? Remember, if I halved it to get 5, the other half should be there too. Half of it was spent going up, and the other half was spent coming down. What is the velocity of the rocket at the maximum height? I want you to answer that. What do you think it is? Well, it's positive going up, and it's negative coming down. So what's there in the middle? You guys should be able to know that. Okay, now we're looking at what is the velocity of the rocket just before it hits the ground right here. Okay, it gives us this formula: velocity final is equal to our initial velocity plus acceleration times time. Okay, where t is the time it takes the rocket to fall from the maximum height. We said 5 seconds. Our initial velocity, well, if it's at the maximum height, our initial velocity is 0, and acceleration is negative 9.8, and our time, we said 5 seconds. Okay, if we multiply those up, we get negative 49. Okay, negative 49, and it's our velocity, so our unit is meters per second. Okay, so that's how fast it was going just before it landed. Okay, so if we took the slope here, it'd be negative 49, just right there at that point. So on this one, saying what's the initial velocity? Remember, everything's even. Okay, so I'm finding the slope right here. What do you suppose it is if everything is even? This point should be the same as that point. Okay, we landed at 49 meters per second coming down. How fast was it launched up? Okay, that'll take a little bit of thinking, but you should be able to get it right there. Number 6, based on the initial velocity from number 5 and the time it took the rocket to reach the max height from number 1, calculate the maximum height reached by the rocket. Okay, so we're going to use that formula. X final is x initial plus velocity initial times time plus 1/2 a t squared. Our x initial, well, we started on the ground, so what are we going to call that position? We'll call it 0, right? Plus our initial velocity, if you didn't already get it, should be 49. Multiply that by our time, which is 5, plus 1/2 times negative 9.8, and we're going to multiply that by time squared. We said 5 was our time that it took to get to the top, and we'll square that. Okay, so then we will pull out our calculator, and we will type those numbers in for our answer. Here's mine. 49 times 5 plus 1/2 times negative 9.8 times 5 squared. Oh my gosh. There it is. And we get 122.5. What's our unit? Well, it's asking us for the maximum height. So what do we measure height in? Measure it in meters. Okay, there it is. There's the front page. Let's see what else. Okay, state Newton's first law. You should be able to do that. If you don't remember it, Google it. Should be on yesterday's assignment. The rocket starts off the launch pad at rest. Describe what causes the state of motion of the rocket to change. Okay, why did it launch up? You're going to describe that in your own words. Okay, stage 1. Okay, so what are we doing here? Rocket goes through 4 distinct phases for the launch. For each stage, draw the free body diagram of the acting forces on the rocket, and we're going to label the forces. Okay, so stage 1. Remember, we're supposed to draw just some form of an image that looks like what we're talking about. Okay, here's going to be our rocket. There it is. Okay, so then now we're going to label our forces. The first one we always draw, remember, well, first off, the rocket is resting on the launch pad. So our first one is an arrow going down, and that's our force due to the weight, right? And now the rocket is not moving, so there should be a balanced force. Notice the arrow is about the same length, and that force is our normal from the ground, normal force. Okay, I'll do one more here with you. The instant that the rocket is accelerating upward from the launch pad. Okay, so remember, we're going to draw the rocket. You guys are going to do stage number 3 and 4 by yourselves. Hopefully these will help. Okay, there's our rocket. There it is. As always, we're going to draw our weight force. Okay. And then, well, it's accelerating upward. Whoops. It's accelerating upward on this one. So that means that the arrow going up should be much larger than the weight force. Okay, so I'm going to draw just a ridiculously long arrow here. Okay, so the arrow is going up. I'm going to call that force an applied force. Okay, an applied force from the thrust. So there it is. Remember, it's accelerating really fast to go upwards, right? So we have this huge arrow going up. Okay, stage 3, you're going to draw the rocket is in air after the initial launch. Okay, it's in free fall. There's no more force acting on it other than the gravity, right? So draw that one here. The instant the rocket lands on the ground and the ground stops its motion. Okay, so you're going to draw that one on stage 4. The rocket might be upside down at that point, right? Okay, good luck there. I'm going to go on to the next slide, where we're talking about Newton's second law. Okay. All right, so we're calculating acceleration. Given that the mass of the rocket is that, and that the rocket is accelerating from rest to its initial launch velocity in a time of 0.2 seconds. So I'll get you guys started on that. We're going to use the formula. Remember, we're trying to find the acceleration. We already know the mass, and we know that also force equals mass times acceleration. So we're going to calculate that here, right, on part B. But first, we need to find the average acceleration. Remember that acceleration is velocity final minus velocity initial divided by time. So our velocity, I'll give you that, the velocity final, that you're going to find from this problem right here, which we put that number right here. Okay, for number 5. Number 5 is right there. Just make sure you put your unit, and it is positive because it's going up. Okay, so that's going to be your final velocity minus your initial velocity. So So whatever that number is that I just told y'all right there, minus your initial velocity. What's your initial velocity? Well, how fast is it going at the beginning? 0, right? Over the time of 0.2. And then you're going to do that, and you're going to get whatever you get. Okay, and then you're going to find the force. Now we've got mass. There it is. Now we've got acceleration, whatever this is. You're going to multiply those two and get your answer for B. Once the rocket's in the air, the only force acting on it is gravity. Calculate the average net force acting on the rocket due to gravity. This is acceleration. Okay? That's acceleration. You already know the mass. You guys got this. Believe in yourself. I do. Given the velocity of the rocket just before it hits the ground and the mass of the rocket is that, calculate the average acceleration of the rocket in the time it takes to stop during impact. Okay? The impact is 0.1 seconds. So this will be the same concept as here, only now your velocity initial is going to be that negative 49, right? Because that's how fast it's going just before it hits the ground. So your velocity your velocity final is negative 49 minus your initial velocity. Your velocity final would be the 0, and then your initial velocity would be the negative 49 because it's going down and it hits the ground and stops at the end. That's the final 0. Okay. And then your time is 0.1. So same concept there, just doing it on this number 13. Hopefully that made sense. Calculate the net force that the ground exerts on the rocket. So basically just like part B, right? Alrighty. Now we're going on to Newton's third law. Remember, every action, there's an equal and opposite reaction force. Describe the main action and reaction pair during each stage of the journey of the rocket. Okay, so I already talked about stage 1 and stage 2, right? Stage 1 is the rocket resting on the launch pad. Stage 2 is the instant the rocket is accelerating upward. Stage 3, the rocket is in the air after the initial launch. It's in free fall. And stage 4, the instant the rocket lands on the ground and it's stopping motion. Okay, so I'll go through stage, let me see. Y'all should be able to do easily stage 1. Stage 2, stage 3, and stage 4 are kind of the trickier ones. I'll do stage 3. The rocket is in the air after the initial launch. Okay, so the action-reaction pair is the Earth is pulling the rocket down. What's the reaction? Remember, reaction just means you're switching the two objects. And the switching rocket with Earth. Rocket is pulling the Earth not down, right? The rocket's not pulling the Earth down, it's pulling it up. Now, it's with such a small, tiny force that it doesn't end up doing anything, but it still is the action-reaction pair. Okay? Next one, the instant that the rocket lands and the ground is stopping its motion. So, what happens? Once the rocket lands, the ground stops. What ends up happening? Okay, so if the rocket lands, the rocket lands, right? So it pushes the ground down. Okay, I want you to think, what's the reaction for this action? The rocket's pushing down, on the ground. So here's the ground, it's pushing it down. So what's the ground going to do? The ground, we switch them out, pushes the rocket. Well, is the ground pushing the rocket down? No, it's pushing it up. if it was pushing it down, then the rocket would keep accelerating as it went into the ground, which does not happen. Okay, so there it is. Hopefully that helps. Write your other 2 guys, and we will see you another time. Hope that helped, and enjoy your weekend. If you watch this on Friday, it's actually Thursday right now. So anyways, I'll talk to y'all later. Goodbye.